This video covers absolute value inequalities. It's an older topic, so I want to make sure I go over it for the final. Absolute value bars, if you remember, are what change something inside to positive no matter what it is already. So if there's a -4 inside of absolute value bars, that becomes a +4. If it was already a +4, it stays as a +4. So it doesn't change anything to negative, it just makes whatever's inside positive. Now when we deal with absolute value inequalities, it gets a little bit trickier, but it's not too bad. Let's say you have 2 times the absolute value of x minus 4 is less than or equal to 8. In this case, our first goal is to get the absolute value part, x minus 4, by itself. To do that, we're going to go ahead and get whatever is outside of the absolute value part by itself, or away. So if we've got a 2 multiplying by x minus 4, the opposite of that is 2 divided out. The 2's reduce to 1, or cancel out if you want to call it canceling out. So what we end up with is the absolute value of x minus 4 is less than or equal to 4. Now that we've got the absolute value part by itself, we can create two problems. Because x minus 4, that whole part could have been negative originally, or it could have been positive. And then the absolute value part turned it into a +4. So to double check both of our options, we want to make two different problems. So we'll go ahead and make two different problems. When we make our problems, we'll leave one just like it was originally, but we don't need the absolute value bars anymore. So that problem should be exactly the same. The other one that we make, the inside of the absolute value part stays the same. The difference is that we're going to change our answer to a -4, because the part inside of the absolute value part could have been negative. And because we're changing the answer's value from a +4 to a -4, we do need to flip the inequality symbol. So you'll notice that the inequality symbol originally said that the absolute value of x minus 4 was less than or equal to 4. Now it's more than or equal to -4. The next step is just to solve them like we would any other equation. Go ahead and isolate for x. On the original one, x minus 4 is less than or equal to 4. We can go ahead and add 4 to both sides to move that 4 over, so that we get x is less than or equal to 8. That is one of our answers. We do get one more answer. The other answer, we're doing the same operation, adding 4 to each side, but because our answer was a -4, it's going to be a different value now. We end up with x is more than or equal to 0, because the -4 and the +4 canceled out. So that's how you would do absolute value inequalities. There is one little thing you do need to worry about if you're dealing with absolute value inequalities, really when you're dealing with any inequality. If you ever multiply or divide by a negative number, you do need to flip the inequality symbol. So you do end up with cases where you have an inequality like the right one, x minus 4 is more than or equal to -4, where you flipped it because you changed the answer. And you can have another situation where you have to flip it again because you ended up dividing by a negative number. So you want to watch out for those situations. Make sure you flip the inequality symbol when you are trying to find the answer. I'll show you a quick example. The absolute value of -2x plus 4 will be less than, let's say, 12. In this case, when we do our two problems, since this absolute value part is already by itself, we don't need to deal with anything else beforehand. So we end up with negative 2x plus 4 is less than 12, just like it was originally. And over here on the right for our second problem, we'll do negative 2x plus 4 is now more than negative 12. So we flipped it for that second part. Now when we do the operations, we need to worry about that negative division. With that negative division, we're going to flip our signs. So first, let's do negative 2x plus 4 less than 12. We subtract 4 to get rid of it. So we end up with negative 2x is less than 8. Now we divide by a negative 2, and because we're dividing by a negative, we need to flip that inequality symbol. So now we have x is more than negative 4. Do the same thing for the right. For negative 2x plus 4 is more than negative 12, same procedure, subtract 4 to both sides. We end up with negative 2x is more than negative 16. And when we divide by negative 2, we need to remember to flip the inequality symbol. So now x is less than a positive 8. And that's the basics of absolute value inequalities. Right? You do pretty much always get two answers unless you get a situation where both answers are 0. In that case, you just have one answer. So always look for two answers when you're looking at absolute value inequalities. Okay? And that should be it for this video.